let's talk about something that's quietly changing the game and how we work with AI. It's called meta-prompting, and it's all about this wild idea. What if the AI could start writing its own prompts?
I mean, we've all been there, right? You spend what feels like forever tweaking a prompt. You're adding words, cutting sentences, just trying to get it perfect. And the AI still gives you something completely out of left field. It's that same frustrating loop. You adjust, you test, you burn through tokens, and you're just stuck in this endless cycle of trial and error. It's exhausting. But what if that whole struggle just disappeared? What if the AI could take on that burden? Imagine an AI that can write, improve, and even debug its own instructions. Well, that's exactly where we're headed with meta-prompting. So here's the game plan for today. We'll kick things off with that manual prompting problem we all know so well. Then we'll clearly define what meta-prompting is. We'll see how it turns this whole process from an art into real engineering, look at how it works, check out a few methods, and then we'll take a peek into our self-instructing future. All right, first things first, let's get right to it. What is meta-prompting? Because it really is a fundamental shift in how we think about talking to these models. In a nutshell, meta-prompting is when you use an LLM to generate or fix another prompt. So instead of you writing the final instructions yourself, you write a kind of master prompt. This master prompt's only job is to tell the AI how to create a better set of instructions for the actual task. You're teaching it how to teach itself. And this is a super important distinction to make. You're probably familiar with few-shot prompting, right? That's all content-driven. You give it examples and say, hey, copy this style. Meta-prompting, on the other hand, is structure-driven. It's not about examples. It's about defining the rules, the logic, the format. It's the difference between saying, copy this, and here's how to think. That's a huge leap. So, okay, it's a cool idea. But why should you care? Why do we actually need to move from this crafty art form to a more engineered approach?
Well, there are some really compelling reasons. For one, it gets us off that roller coaster of unpredictability. You know how it is? Manual prompting is slow, and a tiny change can break everything. Second, it's about cost. Piling on examples for few-shot prompting gets really expensive with token usage, especially in production. This is way more efficient. And finally, you have scalability. You can't have your whole company relying on one prompt genius. You need a repeatable system, and that's what this delivers.
And that's really the perfect way to put it. This whole idea is about taking prompting out of the realm of guesswork and intuition and turning it into a predictable, reliable engineering discipline. Okay, so let's pop the hood and get a little more technical. How does this all actually work? What are the architectures that make this kind of automated prompting possible? One of the coolest and most fundamental concepts is called self-refine. It's a three-step dance that's incredibly powerful. First, the LLM generates a response. But then, and here's the kicker, it stops and gives itself feedback. It critiques its own work. And in the final step, it takes that critique and refines its original output. It can do this over and over, getting better with each loop. And this image shows that loop perfectly. You see the generation, the self-feedback, and the refinement, all happening in the cycle. The most important part, there's no human in that loop. It's an autonomous system for improvement. But we can get even more sophisticated. Think of search-based optimization. This is where the system doesn't just improve one prompt, it explores many different versions at once. It tests them, scores them, and then keeps only the highest performing prompt to continue building on. It's like a tournament for prompts to find the absolute champion. So that's the big picture architecture. Now let's zoom in on a few of the actual named techniques that researchers and developers are using out in the wild. This gives us a great little snapshot. You've got AP, or Automatic Prompt Engineer, which literally treats prompts like computer programs and searches for the most efficient one. Then there's LCP, which is really clever. It learns by comparing good prompts to bad ones to figure out what makes a prompt effective. And Prompt Agent is fascinating. It actually gets the AI to act like a subject matter expert, using that persona to refine prompts for really specialized tasks. Okay, enough theory. Let's make this totally real with a practical use case you could actually go and build today, the Prompt Debugger. Picture this. Someone on your team writes a prompt, and this is all it is. Create a post for a course. That's it. It's terrible, right? No audience, no tone, no format. The AI has to guess, and the result is going to be random at best. Well, instead of a person having to fix that, a meta prompt can act like a doctor. It automatically analyzes that broken prompt and runs down a checklist. Has a role been defined? Is the audience clear? Is there a format? It diagnoses all the common problems. And then, here's the magic. It doesn't just tell you what's wrong, it fixes it. The system automatically rewrites the vague prompt into a beautifully structured one with clear sections for role, objective, tone, format, and so on. It's an automated quality check, and it's incredibly useful. So let's bring it all home. We'll look at how these ideas are becoming reality with actual tools, and then cover the key things you really need to take away from all this. And I want to be clear, this isn't just some far-off academic concept anymore. Frameworks like DSPy are making this happen right now. They allow you to treat prompts like code modules, and then you use these optimizers, which they brilliantly call teleprompters, to systematically find the absolute best prompts for your program. It's prompting as true software development. So if you walk away with anything today, let it be these 4 points. 1, meta-prompting is what turns prompt engineering from a quirky art into a scalable science. 2, it's all about making the LLM do the heavy lifting to improve its own instructions, which saves everybody time and money. 3, things like self-refinement and search are the engines that make this automated optimization possible. And 4, this is all part of a much bigger trend towards more autonomous, self-sufficient AI systems. And that leaves us with one last, pretty mind-bending question to chew on. We're getting really good at teaching AI how to write better and better instructions for itself. So what happens when it gets so good that it doesn't need us to write its instructions at all?